If bugs make your skin crawl today, be grateful you weren't alive 300 million years ago. Back then, Earth was home to insects so large they almost sound fictional. Dragonflies with wings nearly as wide as birds, millipedes longer than most people are tall, and giant relatives of scorpions lurking beneath ancient rivers. These weren't monsters invented for movies. They were real. So how did the world once allow insects to grow to such impossible sizes? And if it happened before, could it ever happen again? To answer that, we have to travel to a version of Earth that looked familiar, yet operated by very different rules. Long before dinosaurs dominated the planet, vast forests stretched across endless swamps. The air was warmer, the landscape was greener, and hidden among those forests were some of the largest arthropods ever to exist. One of them was Meganeura. At first glance, it looked like an ordinary dragonfly, until it opened its wings. Nearly 70 centimeters from tip to tip, it ruled the skies as one of the largest flying insects ever discovered. Below it crawled another giant, Arthropleura, a millipede that grew well over 2 meters long. Its armored body wound across the forest floor like a moving train of overlapping plates. Despite its intimidating appearance, scientists believe it probably fed on plants and decaying vegetation, rather than hunting prey. Not every giant was a predator. Some just looked terrifying. But if there was one creature you truly wouldn't want to meet, it lived in the water. Jacolepterus, a giant sea scorpion reaching lengths of more than 2 meters, armed with powerful claws and perfectly adapted for ambushing prey. For millions of years, these giants weren't exceptions. They were simply part of everyday life, which raises an obvious question. Why don't we see anything like them today? The answer begins with something you can't even see: the air. Unlike humans, insects don't breathe with lungs. Instead, oxygen enters through tiny openings along their bodies and travels through an intricate network of microscopic tubes. It's an elegant system as long as you stay relatively small. The larger an insect becomes, the farther oxygen has to travel. Eventually, delivering enough oxygen throughout the body becomes increasingly difficult. So why wasn't that a problem 300 million years ago? Because Earth's atmosphere wasn't the same. Scientists believe oxygen levels were significantly higher than they are today. That extra oxygen allowed insects to grow far larger than would normally be possible. But Earth doesn't stay the same forever. Over millions of years, oxygen levels gradually declined, and as the atmosphere changed, the advantage of being enormous began to disappear. But the atmosphere wasn't the only thing changing. The world itself became more competitive. New predators evolved. Flying reptiles eventually conquered the skies. Later, birds arrived. Faster hunters, sharper senses, more efficient bodies. Being gigantic was no longer an advantage. It became a liability. Evolution has no interest in preserving giants simply because they're impressive. It rewards whatever survives long enough to leave descendants. Generation after generation, smaller insects became better suited to the changing world. The giants slowly vanished. So, could giant insects ever return? Probably not. Not because evolution forgot how to build them, but because the Earth that once made them possible no longer exists. The atmosphere has changed. The ecosystems have changed. The competition has changed. Those ancient forests weren't just home to giant bugs. They were part of an entirely different world. The next time you see a dragonfly dart across a pond or a millipede disappearing beneath a log, remember this: you're not looking at ordinary insects. You're looking at the descendants of a dynasty that once ruled the skies and forests of Earth.